Hello everyone, my name is Vicky Sashaya, and in this video today we will learn about the applicabilities and the characteristic of a contour map and how we can interpret them. So let's get started. Introduction to contour maps. Contour maps are powerful tools for visualizing and understanding the topography of a landscape. They depict the elevation of the land through a series of contour lines, providing a comprehensive overview of the terrain. Definition of a contour map. A contour map is a graphical representation of a three-dimensional surface on a two-dimensional plane. It depicts the elevation of the altitude of a geographic area using a series of lines, each connecting a point of equal elevation. Contour maps provide a visual understanding of the shape and features of a landscape, allowing the user to interpret the terrain of topography, identify landforms, and analyze changes in elevation. Characteristic of a contour map. Contour map uses a series of lines to represent areas of equal elevation or the depth of 2D surface. Contour lines are spaced at a constant vertical interval known as the contour interval, which indicates the changes in elevation between the adjacent lines. Contour lines are closed-looped, they do not intersect, and they are evenly spread to indicate the steepness of a terrain. Contour intervals and its significance. The contour interval is the vertical distance between the adjacent contour lines on a topographic map. It represents the changes in elevation between each lines, providing a crucial information on the terrain's steepness and relief. Understanding the contour interval, it is essential for accurately interpreting and analyzing the landscape depicted on the map, as it allows the user to determine the precise elevation, value, and slope gradient. Interpreting contour lines. Contour lines on a map represent lines of equal elevation, allowing us to visualize the shape and topography of the terrain. By closely examining the pattern and spacing of the contour lines, we can gain valuable insight about the landscape, such as identifying ridges, valleys, slopes, and the overall relief of the area. For instance, closely spaced contour lines indicate a steeper slope, while more widely spaced lines suggest a gentler incline. Understanding the meaning of contour interval is crucial for accurately interpreting the elevation changes represented on the map. Identifying landforms using contour maps. Contour maps provide valuable insight into the terrain and can be used to identify various landforms. By analyzing the shape, spacing, and orientation of the contour lines, you can recognize features such as valley, ridges, peaks, and depression. Closely spaced contour lines indicate steep slopes, while widely spaced lines suggest gentle slopes. The direction of the contour lines reveal the shape of the landforms, such as concave valleys and convex hills. Determining elevation and slope for contour maps. Elevation. Contour lines represent points of equal elevation. By observing the spacing and density of the contour lines, you can determine the elevation of different areas on the map. Slope. The closer the contour lines, the steeper the slope. Widely spaced contours indicate gentler slope, while tightly packed lines signify steep terrain. Topography. Analyzing the pattern and arrangement of contour lines allow you to visualize topography including hills, valley, ridges, and other landforms. Application of contour maps. Navigating and wayfinding. Contour maps help with navigation by providing detailed information about terrain, elevation, and landmarks, enabling efficient route planning for hikers, mountaineers, and pilots. Geological and geomorphological studies. Contour maps are essential for geologists and geomorphologists to analyze, understand the shape and structure of the Earth's surface, including the identification of landforms and geological features. Urban planning and infrastructure design. Contour maps are used in urban planning to determine the optimal placement of building, roads, and other infrastructure, taking into account of the topography and drainage pattern of the land. Limitations and consideration. Scale dependency. Contour maps can be limited by the scale at which they are created. Smaller scale maps may omit details, while larger scale maps can become clustered with too many informations. Accuracy concerns. The accuracy of a contour map relies on the quality of the underlying data, which can be affected by factors like terrain measurements, technique, and data processing methods. Interpreting challenges. Interpreting contour maps can be complex as it requires understanding the relationship between the contour lines, elevation, and landform. Proper training and experience are necessary. Environmental changes. Contour maps may not always reflect current conditions as the landscape can change over time due to natural processes or human activities. Key conclusion and takeaways. Versatility of a contour map. Contour maps are invaluable tools that can be applied in various fields from surveying and engineering to environmental analysis and urban planning. Understanding terrain and elevation. Interpreting contour lines allow you to visualize the shape and elevation of the land, crucial for tasks like infrastructure development, route planning, and flood risk assessment. Limitations and consideration. While powerful contour maps have limitations such as potential distortion and need of careful interpretation, keeping this in mind is essential for effective utilization. Continuous learning and expansion. As technology advances, contour map techniques continues to evolve, offering new opportunities for more accurate and detailed representation of the physical world. Hope from this video you learn the applicabilities and characteristics of a contour map and how to interpret them. Thank you.